Welcome. Today we're diving into the fundamentals of Python, one of the world's most popular and beginner-friendly programming languages. Whether you're completely new to coding or looking to brush up on the basics, this journey will help you build a solid foundation. Python is known for its simple syntax and readability, making it a favorite for both beginners and professionals. Throughout this video, we'll explore what makes Python unique, how to get started, and the essential building blocks you'll need to write your first programs. Let's begin our Python adventure together. Python's popularity isn't just a trend, it's a reflection of its versatility and power. From web development to data science, automation to artificial intelligence, Python is used in countless fields. Its clear and concise syntax means you can focus on solving problems rather than getting bogged down by complex code. Plus, Python has a massive community, so help and resources are always available. If you're wondering why you should learn Python, remember, it opens doors to a wide range of exciting opportunities in tech and beyond. Before you can start coding, you'll need to install Python on your computer. The process is straightforward. Visit the official Python website, download the latest version, and follow the installation instructions for your operating system. Once installed, you can access Python through the command line or an integrated development environment, also known as an IDE. Popular IDEs like PyCharm or VS Code make writing and testing your code even easier. With Python set up, you're ready to start your programming journey. Let's write your very first Python program. Open your IDE or command line and type print hello world. This simple line of code tells Python to display the message hello world on your screen. It's a tradition for new programmers and a great way to confirm that your setup is working. Running this code should show the message instantly, giving you your first taste of Python in action. Congratulations, you've just written your first program. Python's syntax is designed to be clean and easy to read. Unlike some languages that use lots of symbols or require you to declare variables in advance, Python lets you write code that looks almost like plain English. Indentation is especially important in Python. It uses spaces or tabs to define code blocks, such as loops or functions. This focus on readability helps you and others understand your code quickly, reducing errors and making collaboration easier. Variables are like containers that store information for your program to use. In Python, creating a variable is as simple as typing a name, an equals sign, and a value. For example, age equals 25 assigns the value 25 to the variable named age. You can use variables to store numbers, text, or even more complex data. Python's flexibility means you don't have to specify the type of data. Python figures it out for you. Python supports several basic data types, each serving a different purpose. The most common are inters for whole numbers, floats for decimals, strings for text, and booleans for true or false values. Understanding these types helps you choose the right one for your task. For example, use an inter for counting, a float for measurements, a string for names, and a boolean for yes/no decisions. Python makes it easy to switch between these types as needed. Strings are sequences of characters, like words or sentences. In Python, you create a string by putting text inside single or double quotes. For example, name equal Alice or greeting hello. You can combine strings using the plus sign or accent individual characters using square brackets. Python also offers many built-in functions for manipulating strings, such as changing case or finding specific words. Strings are essential for handling user input and displaying information. Python handles numbers with ease. You can use inters for whole numbers and floats for decimals. Basic arithmetic operations like addition, subtraction, multiplication, and division are straightforward. For example, result equals 5 plus 3 calculates the sum. Python also supports more advanced math with built-in functions and libraries. Whether you're calculating totals, averages, or more complex formulas, Python's number handling is both powerful and intuitive. Booleans are a special data type in Python that represent truth values, true or false. They're often used in decision-making, such as checking if a condition is met. For example, is adult equals age equals 18 assigns true if age is 18 or more. Booleans are the backbone of control flow in your programs, helping you write code that responds to different situations. Lists are one of Python's most useful data structures. They let you store multiple items in a single variable, like a shopping list or a group of numbers. You create a list by placing items inside square brackets separated by commas. For example, fruits equals apple, banana, cherry. Lists can hold any type of data, and you can add, remove, or change items easily. They're perfect for organizing and processing groups of data. Besides lists, Python offers tuples and sets for storing collections of items. Tuples are like lists but can't be changed after creation, making them useful for fixed data. You create a tuple with parentheses, coordinates equals 10, 20. Sets, on the other hand, store unique items and are great for removing duplicates. You create a set with curly braces, colors equals red, green, blue. Each has its own strengths depending on your need. Dictionaries are another powerful data structure in Python. They store data as key-value pairs, making it easy to look up information quickly. For example, student equals name, Alice, age 20. You access values by their keys, not by position. Dictionaries are perfect for situations where you need to associate specific labels with data, like storing user profiles or configuration settings. Interacting with users is a key part of programming. In Python, you use the input function to get information from the user and the print function to display messages. For example, name equals input what is your name asks the user for their name, and print hello name greets them. This simple interaction forms the basis for more complex programs that respond to user input. Comments are notes you add to your code to explain what it does. In Python, you start a comment with the hash symbol. Comments are ignored by the computer but are invaluable for anyone reading your code, including your future self. They help clarify complex sections, describe your logic, or mark areas that need improvement. Good comments make your code easier to maintain and share. Like many other languages, Python uses indentation to define code blocks. This means you must use consistent spaces or tabs at the beginning of lines to group related code. For example, the body of a function or a loop must be indented. If your indentation is inconsistent, Python will show an error. This rule encourages clean, organized code and helps prevent mistakes. Operators are symbols that perform operations on variables and values. Python supports arithmetic operators like plus, asterisk, and for math, as well as comparison operators like equals equals and equals for checking equality. You'll also use logical operators such as and, or, and not to combine conditions. Mastering operators lets you write more powerful and flexible code. Conditional statements let your program make decisions. In Python, you use if, elif, and else to control what happens based on certain conditions. For example, if age equals 18, print adult, checks if someone is an adult. These statements help your code respond dynamically to different situations, making your program smarter and more interactive. Loops allow you to repeat actions in your code. Python offers two main types, for loops and while loops. A for loop is great for iterating over a list or range of numbers, while a while loop repeats as long as a condition is true. For example, for I in range 5, print I prints numbers 0 to 4. Loops are essential for tasks like processing data or automating repetitive actions. Functions are reusable blocks of code that perform specific tasks. You define a function using the def keyword followed by a name in parentheses. For example, def greet, print hello, creates a simple greeting function. Functions help organize your code, avoid repetition, and make your programs easier to manage. You can also pass information to functions using parameters. You define a function, you can specify parameters, placeholders for information the function needs. When you call the function, you provide arguments, which are the actual values. For example, def add a b, return a plus b defines a function with two parameters, and add 3 5 calls it with arguments 3 and 5. This makes your functions flexible and adaptable to different situations. Functions can send information back to the part of the program that called them using the return statement. For example, def square x returns the square of a number. Return values let you use the results of functions in other parts of your code, making your programs more powerful and modular. Variable scope determines where a variable can be accessed in your code. Variables defined inside a function are local to that function, while those defined outside are global. Understanding scope helps you avoid naming conflicts and ensures your code behaves as expected. It's a key concept for writing reliable, bug-free programs. Errors are a normal part of programming. Python provides tools to handle them gracefully using try and except blocks. For example, you can try to run some code, and if an error occurs, handle it in the except block. This prevents your program from crashing and lets you provide helpful messages or fallback options. Learning to handle errors is essential for building robust applications. Python's power comes from its extensive library of modules, pre-written code you can use in your programs. You import a module using the import keyword. For example, import math gives you access to advanced math functions. Modules save time and effort, letting you add new features without starting from scratch. Math module is one of Python's most useful built-in libraries. It provides functions for advanced calculations such as square roots, trigonometry, and constants like pi. To use it, simply write import math at the top of your code. Then you can call functions like math sqrt16 to get the square root of 16. The math module is a great example of how Python's libraries can make your life easier. Python makes it easy to read from and write to files. You use the open function to access a file, then read or write to process its contents. For example, with open data txt r as file content equals file read, reads the entire file. File handling is essential for tasks like saving data, processing logs, or working with large datasets. Combining loops with lists lets you process multiple items efficiently. For example, you can use a for loop to print each item in a list. For fruit in fruits, print fruit. This pattern is common in Python and helps you automate repetitive tasks, analyze data, or transform collections of information. List comprehensions are a concise way to create new lists by transforming or filtering existing ones. For example, squares equals x asterisk x for x in range 10 creates a list of squares from 0 to 9. This feature makes your code shorter and often easier to read, especially when working with large datasets or complex transformations. Slicing lets you extract parts of lists or strings using a simple syntax. For example, numbers 1, 4 gets items from index 1 up to but not including index 4. Slicing is powerful for working with subsets of data, revering sequences, or skipping elements. It's a handy tool for manipulating collections in Python. Python provides many built-in methods for working with strings. You can change case with upper or lower, find words with find, or replace text with replace. These methods make it easy to clean, search, and modify text data, which is especially useful in data processing and user interfaces. Debugging is the process of finding and fixing errors in your code. Python's error messages usually tell you what went wrong and where. Reading these messages carefully can save you a lot of time. You can also use print statements to check the values of variables at different points in your program. With practice, you'll become more confident in tracking down and solving bugs. Python includes a built-in help function that provides information about objects, functions, and modules. For example, help print shows details about the print function. This is a great way to learn about new features or clarify how something works right from your coding environment. Once you're comfortable with the basics, try building small projects to practice your skills. Ideas include a calculator, a to-do list, or a simple guessing game. These projects reinforce what you've learned and help you gain confidence. Start small and gradually add new features as you improve. Python's ecosystem includes thousands of libraries for tasks like web development, data analysis, and machine learning. Popular examples include requests for web requests, pandas for data analysis, and matplotlib for plotting graphs. Exploring these libraries can help you discover new possibilities and expand your programming toolkit. Step 8 is the official style guide for Python code. It provides recommendations on how to format your code for maximum readability, including nomming conventions, indentation, and line length. Following PEP 8 helps your code look professional and makes it easier for others to read and contribute to your projects. While comments are helpful, it's important not to overuse them. Focus on writing clear, self-explanatory code and use comments to clarify complex logic or highlight important details. Well-placed comments make your code easier to maintain and understand, especially in larger projects. One of Python's greatest strengths is its vibrant community. There are countless forums, tutorials, and open-source projects where you can learn, ask questions, and contribute. Whether you're stuck on a problem or looking for inspiration, the Python community is always ready to help. Engaging with others can accelerate your learning and open up new opportunities. As your projects grow, organizing your code becomes more important. Use functions, modules, and clear nomming conventions to keep things tidy. Breaking your code into smaller, manageable pieces makes it easier to debug, test, and expand. Good organization is the key to successful programming in the long run. Version control systems like Git help you track changes to your code, collaborate with others, and avoid losing work. Even for small projects, using version control is a good habit. You can save snapshots of your code, revert to previous versions, and work on new features without risk. Learning the basics of version control will serve you well throughout your programming career. The official Python documentation is a treasure trove of information. It covers every feature of the language with examples and explanations. Learning to navigate the documentation will help you solve problems faster and deepen your understanding of Python. Bookmark it as a go-to resource as you continue your coding journey. Now that you've mastered the fundamentals, consider exploring more advanced topics like object-oriented programming, web development, or data science. Python's flexibility means you can apply your skills to almost any field. Set new goals, experiment with new libraries, and keep building your knowledge. The possibilities are endless. Every beginner makes mistakes, and that's part of the learning process. Common errors include forgetting to indent, mixing up data types, or using the wrong variable names. Don't get discouraged, each mistake is a chance to learn. With practice, you'll spot and fix errors more quickly, becoming a more confident programmer. Learning to code can be challenging, but it's also incredibly rewarding. Set small, achievable goals and celebrate your progress. Join coding communities, share your projects, and don't be afraid to ask for help. Remember, every expert was once a beginner. Stay curious, keep practicing, and enjoy the journey. We've now covered the essentials of Python, from installing the language to writing your own programs. Remember, programming is a skill that grows with practice and curiosity. Keep experimenting, building, and learning. Python opens up a world of possibilities, and your journey is just beginning. Thanks for joining this introduction to Python fundamentals. Happy coding!